Okay, kiddos. Here is number 20 from page 240. So it describes this situation. It says there's a thin thread. So here's the thin thread, and it's holding these two carts together. There's a spring that's about to go boing and push them apart once the thread burns. So here's your match. You burn the thread. The spring pushes each cart this way, and the 4.5 kilogram cart goes that way, and the 1.5 kilogram cart goes that way. Now, I'm hoping it makes sense that if they're initially at rest, they're not moving, this is going to end up going faster than this one. So that probably just kind of makes sense to you, which ends up being correct. Here's how we actually solve. The question tells us that the lighter cart ends up with the speed of 27 centimeters per second to the left. Notice how I immediately converted that to meters per second. And this is a simple conservation of momentum. So the momentum before the collision is the same as the momentum after the collision. And when I say the momentum, I mean the momentum of the system, which means the momentum of both carts together. So the momentum of both carts together is 0. Therefore, the momentum after the collision, these have to cancel out. Oops. So I have mass times velocity, and this is equal to mass times velocity plus mass times velocity after the collision, before the collision and after the collision. So solving for v, let's see, this is all 0, so we add and then we divide and we get this. So if you look at this, 0.09, that's like a third of this, which actually kind of makes sense. 3 times the mass, it's gonna have 1/3 the velocity, and it's in the the sign is positive, so it's going to the right. Okay, good work.